Hello, and welcome to Mrs. Schlecht Explains How to Add, Subtract, Multiply, and Divide whole numbers and decimals. All right, before we begin, a couple of things. One, this should all be review. Two, I am going to be using the same digits in every single one of these problems that I show you. The reason I'm choosing to use the same digits over and over again is to really show you the importance of place value, lining up your digits, and lining up that decimal. Third, if I were you, I'd grab a piece of paper because that might be pretty handy. What type of paper, you ask? Well, in my experience, some of the best paper to use when I am trying to do math with all these different digits and place value is graph paper. I know you can't see it super well right now, but this is graph paper. So it has like little tiny grids. You guys have probably used this before in your life, I think, and you might have. Now, the reason that I think graph paper is super, super great to use when you are adding and subtracting, multiplying and dividing decimals is because you can line it up really nice and it helps you stay organized. So if you want to use graph paper, the way I would recommend it is that one number goes in each box and you line up your place value. Just a little tip. All right, let's get to some math. Here's part one, addition. Now, you've been adding ever since you were like in kindergarten and first grade. You should be experts at adding, right? Adding is just when we are increasing a number, when our number is getting larger. So let's start our first problem. All right, for our first problem, we have 1,354 plus 50. Do you remember that I said we're going to be using the same digits? What I'm talking about is 1, 3, 5, 4, 5, and 0. Those numbers will be in every single problem that we do today. Let's just add. Now, do you notice that I have my 4 and my 0 lined up? Why do I have it lined up like that? Did you say because of place value? Because 4 ones and the 0 are both in the ones spot? If we notice, all of our digits are lined up with their correct place value. What I mean by that is, this 4 is 4 ones. This 0 means that there's 0 ones. So I have my ones column lined up. This 5 is in my 10 spot. This 5 is in my 10 spot. That's why they're buddies. That's why they're lined up. The thousands and the hundreds don't have a buddy in this number. That's why there's nothing underneath there. Remember, take the time to set up your problem neatly and organized so that you'll be successful. All right, let's start adding this up. So 4 plus 0, we all know is 4. The 4 just goes directly under here. Remember, make sure you keep it all lined up so that your place value is still in the same order. You're actually going to get the correct value that you're looking for. All right, now we have 5 plus 5. 5 plus 5 is 10, but we are all brilliant. We all know that I can't put 2 digits in one spot, so I have to carry it over, right? So I put my 0 down here, and then I have to carry that extra 1 I just made to above the 3. Now I have 3 hundreds plus that extra 100 that I just made makes 4 hundreds. Okay? And I got nothing for the 1, so it just comes right down. What we did is we just added these two whole numbers together. We added 1,354 plus 50 and got another whole number of 1,404. But now let's add a decimal in our original problem and see how that changes things up a bit. All right. Now, here's the same digits, both decimals, and our place value has shifted a little bit. Let me explain to you what's up here. So on the top, we have 135 and 4 tenths. So instead of having 1,354, I just divided that by 10, and that's how that decimal got scooted over a little bit, right? But then down here, I have 5 tenths, or we can also call this number 50 hundredths. Now you'll notice that I only have 1 number after the decimal up here and 2 over here. But do you remember that decimals go on and on and on and on and on and on and on forever and ever and ever, right? So what's actually behind this 4? 0, 0, 0, 0. So I'm going to use this 0 to help balance the two numbers that I'm trying to add together to help my brain stay organized so that I know that I am adding what I need to be adding, okay? So this is just an imaginary 0. Did it change the value? Nope, it just changed the look of it, right? But remember, if I added a 1 right here, would that have changed the value? Oh yeah. All right, so now let's add. So 0 plus 0, 0. Easy. 4 plus 5 is 9. Now, when I'm adding and subtracting decimals, my decimal just comes straight down. 5 plus nothing is 5, 3 plus nothing is 3, and 1 plus nothing is 1. So our final answer is 135 and 9/10, or we could call this 90 hundredths, right? Do you notice how important it was to line up my decimal? Because for adding, I can just bring it right down. Remember, your same rules of adding apply. If you need to carry something over, you still carry something over, right? Part 2, subtraction. All right, here's our first problem. In this problem, we have 1,354 minus 5. So you'll notice that I still have that placeholder 0 behind the decimal. That's because I want you to know that this is just a whole number 5, all right? So if we're remembering what happened when we were adding and we had more digits behind the decimal in one number than the other, what was that magic little thing that we added that helped us balance our problem? Do you remember? When Mrs. Schlecht is going like that, I wonder if that's a clue. Did you say add a 0? That's right. Let's add a 0. So not only am I going to add a 0, I'm going to add a decimal point behind the 4 and then my 0, because I want you to know that this is a whole number. This ain't the decimal. This is a whole number. The decimal goes right here, and then we have that 0. All right, now my equation, my numbers have the same number of digits behind the decimal of each other. So now let's subtract. All right, 0 minus 0 is 0. Again, my decimal is just going to come straight down. 4 minus 5. Can I do that? No. Okay, real talk. One of the big mistakes that I see is kids forgetting that you can't take a smaller number and then subtract a larger number from it, right? I can't do 4 minus 5. That's not 1. You gotta borrow. Borrow, still a thing. Regrouping, still a thing that happens. Just FYI. So 4 minus 5 is not 1. It's not 9. I can't do that. What do I need to do? I need to regroup. I need to borrow. So what I'm going to do is I'm going to come over here to the 5 tens, and I'm going to take one of those tens away, and I'm going to give it to my 4, so that my 4 becomes 14 instead. So I'm going to take this. This only becomes 4 tens, right? And then I carry that extra 10 over to the 4. 14 minus 5. Can I do that? Yeah, that's doable. So 14 minus 5 is 9. 4 minus nothing is 4. 3 minus nothing is 3. And 1 minus nothing is 1. So in this problem, our answer is 1,349. Now, let's change up this decimal place a little bit and see how much fun that is. All right, here's our new problem. Do you notice something a little bit different here? We have 13 and 54 hundredths, but then I put a 0 here because we don't have a whole number in this next case. So this 0 before the decimal just shows you that there is no ones. There's no whole number in this decimal. Let's subtract. So 4 minus 0 is still 4. 5 minus 5 is 0. Again, my decimal just comes straight down. 3 minus 0 is 3. And 1 minus nothing is 1. So in this problem, 13 and 54 hundredths minus 50 hundredths is 13 and 4 hundredths. Again, remember, when you are subtracting or you're adding, the same rules apply to whole numbers. You're still borrowing, you're still carrying. Those same rules still apply. Part 3, multiplication. So for our first problem, we're just going to work with whole numbers to just practice multiplying. So in this case, we have 1,354 times 5. So we have 5 times 4 is 20. I put my 0 down there. What do I need to do with that 2? What's that? I couldn't hear you. Did you say we need to carry the 2 over to the 10 spot? You are a rock star. You're right. So I'm going to do my 2 up here. Now I have 5 times 5, which we all know is 25, but 25 plus that extra 2 is going to give us 27. I'm going to put my 7 down here. And now I got to carry another 2 over to above my 100 spot to the 3, right? So now I'm going to look at 5 times 3, which is 15. But 15 plus 2 would be 17. So again, I'll put my 7 down here. I'm going to carry my 1. And now we have 5 times 1 is 5, but plus that extra 1 is 6. And don't forget to add your comma so that you can show other people you understand this is 6,000. So when we multiplied 1,354 by 5, we got 6,770. All right, here's the next problem I want to look at. Notice I have the same digits, but I included 2 decimals now. So now our problem is 13 and 54 hundredths times 5 tenths. Now, here's a little tip. When you are multiplying, forget about the decimal at first. Just multiply, okay? I'm not going to forget about the decimal, but when we're multiplying, that's kind of one of our last steps. So just hang tight on that. So you'll notice before we start multiplying that I have 5 tenths, 5 tenths, and then I have 4 hundredths, and I don't have anything underneath here. Now, I know in my brain, and I know you know in your brain, that there's actually that little placeholder 0, a little imaginary 0 right behind there. Also added that extra 0 to help us stay organized, to help us understand that this is 4 hundredths and I have 0 hundredths in this number. This is 5 tenths and this is 5 tenths, right? Place value, organizing stuff, having stuff in a category all lined up. Really simple step, but it really goes a long way to helping you be successful. Just a little tip. So remember, you have to start with your 0 over here, but this should be pretty quick, right? Now that I have added with this first number, I need to have that placeholder 0 on the bottom so that I know, well, I'm now multiplying, not by 5, I'm multiplying by 5 tenths, right? Or by 50 hundredths, right? This 0 right here is helping us hold our place. Now I'm just going to multiply again. 5 times 4, we know is 20, but I can't put 2 digits in one spot, so I have to carry something over. So again, 5 times 4 is 20. There's my 0 for the 20, but I'm going to put my 2 up here. 5 times 5 is 25, plus that extra 2 will give us 27. There's my 7, I'm going to carry my 2. Now I have 5 times 3, that's 15, plus those 2, that's 17. There's my 7. Again, I'm going to carry my 1. I have 5 times 1, that's 5, plus 1 is 6. Are we done yet? Because I still have the 0, right? But this will be pretty quick again. So now I'm going to have 2 placeholder 0s because I've done my hundredths, I've done my tenths, I'm now working in my whole numbers, right? This should go easy though. 0 times 4 is 0. 0 times 5 is 0. And 0 times 3 is 0. And 0 times 1 is 0. All right, now that I have all of my partial products, I can add them up. Again, don't worry about the decimal quite yet. Let's just add. So I have 0 plus 0 plus 0 equals 0. 0 plus 0 plus 0 equals 0. 0 plus 7 plus 0 equals 7. 0 plus 7 plus 0 equals 7. 6 plus 0 is 6. And then that's just a 0, right? All right, but what about those decimals? I hear ya. Let's talk about them. It's a little bit different than adding and subtracting. I can't just bring my decimal down. That's because I'm multiplying the place values, right? So if we think about it, I just multiplied some hundredths by some other hundredths. So I'm not going to get 100, right? What's 100 times 100? 10,000. You're right. See, you're right. So that means that this number needs to have a 10,000th spot. Okay, that might kind of sound a little tricky, but here's a quick tip for you. Count up your decimal spots in both your numbers, and then that's how many decimal spots you need in your number. What do I mean by that? How many spots do I have behind the decimal here? 1, 2, 3, and 4. 4 spots. That means that in my answer down here, I need 4 numbers behind the decimal. So I'm going to start at this back, this 0, the last 0 right here, and I'm going to count 4. 1, 2, 3, 4. My decimal needs to go right there. Okay. Again, the reason that I knew where to put my decimal is because I counted the places up here. 1, 2, 3, 4. 4 numbers behind the decimal in my problem. I need 4 numbers behind my decimal in my answer. So in this case, the answer to 13 and 54 hundredths times 50 hundredths is 6, and 77, we can say 10 thousandths, or we can just say 77 hundredths, because we all know that those zeros don't really add any value, right? All right, here's our second problem. We have 135 and 4 tenths times 5. So that 5 is not 5 tens, it's not 5 tenths, not 5 hundredths, it's 5, it's 5 ones. That's why it's lined up with my other 5, because that is also 5 ones. And now I'm just going to multiply. So now how do you decide where your decimal goes? Well, let's look at your problem. How many numbers do you have behind the decimal here?
Just one.
Just one. So do I have any decimals in this number? Right? So I only need one decimal place in my answer, and that would go right here. So that is multiplying with decimals. Part 4, division. So I know division can kind of be scary, but you got this, don't worry. So let's look at our first problem. So in this first problem, we have 1,354 divided by 5. No decimals at all in this problem. Let's just work on dividing. So first, we're going to look at our divisor. That's like how many groups I want. Remember, your dividend is your big total. That's the whole amount that you're trying to break apart into smaller groups, right? So can 5 go into 1? Can 5 go into 13? How many times? Twice. So 5 can go into 13 twice. I'm going to put that number right up here. 2 times 5 is 10. And now we're going to subtract that. What's 13 minus 10? 3. I'm going to put my 3 down here. And now I'm going to bring down that 5. So instead of just 3, I now have 35. Can 5 go into 35? Yeah, how many times? 7. 7 times. Put my 7 up here. 5 times 7 is 35. Subtract that and I get 0. But wait, I'm not done. I still got to bring down that 4. All right, so now let's look at it. Can 5 go into 4? So how do I represent that? I add a 0. So my 0 is going to go up here. 0 times 5 is 0. I subtract that and I get 4. Now, you might be thinking, oh, so it's 270 remainder 4. Now, that is one way you could write it, and you would be correct. But here's how we could add that number using a decimal instead of having a remainder like that. So if you remember, behind this number, there's actually those zeros, right? There's zeros that just go on and on and on forever and ever and ever. I only need one of them, though. So since this is my decimal spot, I'm just going to move this up really quick. Let's get rid of that remainder 4. And then I'm going to bring down this extra 0. Now, can 5 go into 40? Yeah. How many times? 8 times. So after the decimal, I'm going to put an 8 here. 8 times 5 is 40. I subtract that, I get 0, and now I have no remainder. But now, let's do some division with decimals inside these numbers. All right, so here's our next division problem. We have 135 and 4 tenths. Notice that decimal divided by 5. 5 is still a whole number. There's still no decimals in that 5. It's just 5 wholes. Here's a really important rule. Are you ready? When you are dividing decimals, it is a-okay to have a decimal inside your dividend. So inside the house, decimals, that's a-okay. But when you are dividing with decimals, you cannot, you do not, you will not have any decimals in the divisor. The divisor must be a whole number. We'll get back to that in a second, but I just wanted to put that in your ear real quick. Let's work on some dividing. So since I do not have any decimals in my divisor, I'm good to go. I have one decimal right here in my dividend, so I'm going to just bring that directly up. So it just comes directly up here, okay? Easy peasy. Did I do any math thinking for that? Not really. I just organized my stuff and just brought it up. Okay, so now let's get to some dividing. Can 5 go into 1? Mm-mm. Can 5 go into 13? Mm-hmm. How many times? Twice. So I'll put my 2 right above this 3. 2 times 5 is 10. There's my 10. Now I'm going to subtract that. 13 minus 10 is 3. So I bring that down. Now what do? I bring down that 5. So here's that 5. I now have 35. Can 5 go into 35? Yeah. How many times? 7 times. Now, do you notice that this 5 I just brought down was before the decimal spot, right? That means that that 7 I'm just going to write up also needs to come before the decimal point. So right there. Now I'm going to do 7 times 5, which is 35 again. Subtract that, and we get 0. But wait, there's more. Don't forget about that 4. Now I got to bring this 4 down. Okay, now, can 5 go into 4? Nope, still can't do that. So I need to represent that by putting a 0 behind my decimal. So again, 5 cannot go into 4, so I'm using that placeholder 0 right now to show that relationship. Now 0 times 5, 0. So 4 minus 0 is 4, but I'm still, remember, there's still like those imaginary zeros right behind this number. Forever and ever and ever. I'm going to use one of those imaginary zeros and bring it down so it can work for me. So I'm going to bring down this 0. Now I have 40 instead of just 4. Can 5 go into 40? Yeah. How many times? 8 times. 8 times. So I'm going to put my 8 after this 0 because as you recall, we're now like behind my 0, or I'm sorry, we're now behind my decimal, right? Here's all my numbers that I'm working with. It's after the decimal. Therefore, my answer for my quotient needs to go behind the decimal in that case. All right? 8 times 5 is 40. And 40 minus 40 is 0. So in this case, 135 and 4/10 divided by 5 is 27 and 800. But now, what if I had a decimal where it's not supposed to? How in the world do we work with that? Well, we're going to talk about that now. So in this problem, you might notice that 135 and 4/10, that's the same number that we just dealt with. I didn't mess around with that. We're just going to keep that the same. All right? But over here in our divisor, I have a decimal. Are decimals supposed to be in my divisor? Nope. I gotta fix it. I can't go on until I fix it. And how do I do that? Well, let's think. Let's start using our math brain. How can I get from 5/10 to 5? I just want it to be 5. I don't want it to be 50. I don't want it to be 50/10 or anything like that. I just want 5. So let's think. Think of your place value patterns. Let's think. So think of your place value. All I want to do is just swoop the decimal over 1. And when you're swooping the decimal, you're actually multiplying by 10. That's what you're doing there. So 5/10 times 10 will give me 5. It's the same as swooping that decimal. That's a pretty quick trick for you, but I want you to know what you're actually doing. You're not just swoop, swoop, swooping. You're multiplying by 10. That's what you're doing, all right? Just so you know that. So let's look back at our problem. We now know that in order to get to 5 ones, just 5 whole, right, I need to multiply my divisor by 10. But remember my trick? It's also just like a swoop in the decimal thing. So if I swoop my decimal over 1, oh, check it out. Now it's 5. Woohoo! But I got to keep my equation balanced, right? If I mess around with this side, but then I don't want to mess around with this side, my equation's not gonna give me the right answer, right? It's important that whatever I do over here to my divisor, I gotta do that same thing over here in my dividend, all right? Now remember, it's okay if decimals are still gonna be staying here. That's okay. However, you cannot, you will not have any decimals in this divisor, okay? So now we just swooped it one time over to make this 5. So I'm gonna do the same thing over here. I'm gonna take this decimal and I'm gonna swoop it over once. And now I have 1,354 instead of 135 and 4/10, right? Again, it just happens that this problem will no longer have a decimal right here, okay? But that's all right. I could have had a decimal in my dividend, but where does a decimal never, ever, 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 ever go? Your divisor. All right, so now I have 5 holes right there, and now I have a whole number right here. I'm gonna bring my decimal again, just directly up. And now let's start dividing. Can 5 go into 1? Can 5 go into 13? Yep, we know that it's twice. So I'm going to put again that 2 right above that 3. 2 times 5 is 10. Subtract that, we get 3. Now I bring down the 5. Bring down my 5. 5 can go into 35 7 times. 7 times 5 is 35. Subtract that and I get 0. But then I need to bring down this 4. Notice, since my decimal is now behind the 4, whatever my answer is to this part, it's going to go before the decimal as well, okay? So can 5 go into 4? So I'm going to represent that by putting a 0 to hold that place value. Now, 0 times 5 is 0. So that still gives me 4, but I'm going to bring down my imaginary 0 that's right there. Notice that that 0 came from after the decimal point. So wherever I write my answer to this portion, it's also going to come after the decimal point. All right? Can 5 go into 40? Yeah. How many times? 8. 8 times. So my 8 will go after the decimal. 8 times 5 is 40. Subtract that and we get 0 again. So your answer to this problem, 135 and 4/10 divided by 5/10 equals 270 and 8/10. All right, so now let's just do a quick recap and get some tips for success. All right, Mrs. Schlecht's first tip for success is to stay organized. This means lining up your place value, lining up your decimals, making sure that your 4s look like the number 4, not the number 9. By staying organized, it will help you remember what step you're on and which digits you're messing around with. Tips for success number 2. Remember all of your previous rules. All right, tip for success number 2, remember the rules for addition, subtraction, multiplication, and division. You all know how to do all of these with whole numbers, but the rules still apply even after you're adding that decimal. Remember, regrouping, borrowing, carrying over, those are all still steps, still processes that have to be included when you're doing those decimal operations. Again, it's not like there's some brand new mystical formula for adding decimals. It's the same process. Just make sure you stay organized and you'll be great. For success number 3, check your work. Tip for success number 3, check your work. This is such an important piece and lots of times it gets skipped over. But by checking your work, you can double check that you've answered the question that you're supposed to be answering, that you've done the correct operations, and you can also check that your answer makes sense in the context of that problem. Checking your work, big tip for success. All right, so this was Mrs. Schlecht goes over adding, subtracting, multiplying, and dividing whole numbers and decimals. If you have any further questions, please reach out. Happy learning.